Thank you for joining MasterGraphics Desktop Metal webinar. And kind of today I'm going to talk a little bit about our partnership now with Reselling Desktop Metal and really talk about their approach to metal manufacturing and talk about the studio and shop system. So my name is Kevin Carr. I'm the president of MasterGraphics. We've been in the 3D print space for about 14 years. And very excited about our new partnership with Desktop Metal. So with that, I just wanted to kind of give an overview of why we selected Desktop Metal as a partner, talk a little bit about the key applications and opportunities that we see for additive, and particularly around metal. And then there's obviously this buzzword of additive manufacturing 2.0 and what that means, and how Desktop Metal is really approaching that pretty revolutionary to create some easy steps for metal additive. I'll get into the particular products, and then I'll get into question and answer. So I do have Eric Gold joining me today from Desktop Metal. Eric, I did allow you to speak, so you're muted now, but if anytime you want to join in, you can unmute and speak up. And again, I'm going to try to keep this webinar to about 35 minutes. And then if you have questions or answers, you can throw them in the question and answer box. Everyone's on mute, and we'll answer them at the end. But real quick, for those of you who don't know who MasterGraphics is, we're Midwest based and really cover the central part of the US, go all the way down to Missouri and those type of areas. But you know, really what we are focused on is working with our clients to effectively adopt 3D printing internally. And that's everything from prototypes to production. And you know, our emphasis over the last 5 years has really focused around production, because that's where we see the biggest opportunity for the next growth. And where we're seeing our solution set and our expertise help customers is shorten time to market, reducing cost, right? We also see a big struggle out there of trying to weed through what is hype and what is reality. So we really work with our clients to make sure that they can effectively utilize 3D print. And if it's overhyped, we'll let you know. And then, of course, the current one since COVID is how to address supply chain challenges and, of course, improve innovations. So we see these as kind of the core challenges that we believe additive, in some cases, can improve your business. And we kind of start with the defined process. I'm pretty passionate about it as the owner of MasterGraphics, that we really walk you through, like, what are the pains you're looking to solve? Does additive make sense? What's the ROI? And then even from there, sometimes we figure out it's not a fit, but we have a pretty defined process. We're fortunate to represent some great companies such as HP 3D, 3D Systems, Ultimaker, Dimension, and now Desktop Metal. And I want to get a little bit into Desktop Metal and kind of their history. I will say back in 2015, 2016, when they were founded, a lot of press was given to Desktop Metal. They were coming to the market pretty revolutionary, right? When you compare the traditional EOS and 3D Systems in it. And so they were really trying to bring additive printing, you know, to the industry, make it easier, more accessible. And they kind of brought all these very intelligent people together in Boston and developed this product, right? To be cost competitive, high speed, that type of thing. So the big thing in 2019, they did start shipping the studio. I'll get a little bit into that. The key thing was the kind of removable supports, as opposed to having to get wire EDM or something to cut off a metal part. And then the bigger one, as you follow through, then in just this last year, they started shipping not only the production unit they've installed, which is kind of a high end, but the shop system. And I want to get into that, because that's why I believe Desktop Metal is different than most other technologies out there at this price point, is this ability to print in powder, not simplify the process, and make it accessible to people. And then, of course, the other last thing I'll talk about is Live Sinter, is a software that they use, because printing is only part of the process. Building the build box and how you print things is important, and they have some revolutionary software. And then if you follow them, you know, they are part of a SPAC, this special acquisition company groups. And so they bought EnvisionTech, or merged with EnvisionTech. They made some acquisitions here on Monday. So they continue to grow. But I encourage you, if you go and you look at them on the stock exchange, one of the biggest things that excites me about Desktop Metal is the amount of money they pour into R&D. In 2021, they will put over $40 million in research and development for the product. And to me, that excites me because we are just at the forefront of what they are going to do. And it's why they can create these amazing products, is they're investing a lot of money. Again, having said we were in the 3D print space, if you compare that investment versus traditional 3D print, it's a substantial amount of investment in 3D print. So from a high level, they have 4 products, right? And again, adding more with EnvisionTech and that. But they do have a product that is a composite with carbon tape built in. Even though it's a composite, it's strong, like almost like aluminum. So many of you are familiar with Mark Forge products. It's to compete in that space, make very strong plastic parts. Of course, I'll talk a little bit about the studio system in a minute, but it is designed to be an in-office metal 3D printer. So no need for special rooms, special environments. You literally can place this in an office environment and be creating 3D metal parts. As I mentioned, then you get into the shop system. Now we can kind of up the game, do more batch printing with metal. It's a total turnkey system and allows you to do print into powdered metals so that you can really increase your throughput and, of course, improve your ability to print geometries. And then probably from the original start of Desktop Metal, they have developed a very unique high volume metal 3D printing. This is a niche product in a lot of cases, but for those of you who are looking to produce high volume metal parts, Desktop Metal is someone you want to talk to. As a reseller, we kind of fit in the first 3 quadrants, but in that last one, if you have any questions about getting into truly high volume metal printing, I can connect you with Eric. So when you look at kind of, whenever we're bringing on technology, what does additive? Where does it fit? What's the, why would customers bring this in, or clients? And if you kind of look at the first one, I love talking about innovation. Additive truly spurs on innovation. I've said this, I've been in the print world for the 30 years of my life. And print always added, people needed it, right? It was a requirement. You needed to print documents to assemble. But 3D print truly, for those customers that were early adopters, allowed them to be more innovative. So if you look at kind of that first little column there, it's geometry, right? Machining and tooling really requires simpler jobs. The simpler, the better. Whereas with additive, we can optimize the design. Think of generative designs, think of lightweighting. That's one of the big advantages of additive. Then, of course, you get to customization. This is, again, in typical tooling, you got to retool or reprogram to do things specific. With additive, we can do mass customization. You're already seeing it with kind of our dental implants. You're seeing it with people like Invisalign. Customization continues to be a push by consumers. You're going to continue to see it in automotive. Again, customization from a mass level was not really an option until you get to additive. And then, of course, we talk about process innovation. This gets into time to market, right? You can get to market much shorter when you can either produce parts faster, final one, or produce prototypes. Then, of course, we get into volume. Another big change that Desktop Metal has brought to the market is the ability to bring more volume printing at a more cost-effective. And then inventory. We're seeing this push for digital inventory on demand. No question, every large company has struggled with inventory management, especially during COVID. This is where we kind of talk about supply chain. And, now we're able to have a digital inventory and print on demand. All the big companies, whether it be Caterpillar, whoever it might be, are really working to try to minimize the expense they have in a warehouse and print it on demand. A great example is Amazon, right? Amazon, when you order books, more times than not, they're actually printing that book on demand as it's needed to be shipped out. The same thing holds true for parts. As a service provider, I can tell you about 3 years ago, we wrote off about $100,000 of parts that we needed to support machines that got obsolete over time. And going forward, if we can create parts as needed, it would just be much more cost effective. And then of course the cost to run the equipment. When you look at 3D print versus machining, you basically, again, create the build box, send it to the printer will work. Of course, then you have some involvement on finishing, but really there is a low operator burden when you look at additive. So when we look at these kind of buckets, and this is really coming from desktop, we really do see some real advantages of what additive can do. And where I'm really excited, as I mentioned, is bringing on desktop metal is because of what they can do. So this additive 2.0, we in the past sold some 3D print metal technology from, 3D systems and that type. But again, where I think desktop metal is uniquely positioned is they are making their systems accessible to everyone, right? Getting back to the need of not having a specialized room or specialized trainer. One of the advantages desktop has is the fact that they have a very closed loop system, right? From start to finish, you follow that part, right, from the printer to the sintering station, and it's kind of a closed loop, and it's doing all the calculations for us. And so if you can even see from this operator, just the user interface that desktop has created makes it very usable by just about any user. And then, of course, you get into high volume manufacturing. One of the limitations that additives had around metal is really, you could print 1 or 2 parts and maybe get them out. Or if you were using a laser-based system, it was a little bit slower and expensive. But now we are bringing more high volume metal manufacturing to the market. And so, the other thing is, what has changed over the last 3 years, of course, is the finish, right? We continue to see better improvement in the way the parts are finished and just the overall kind of how they're coming out of the machine. Of course, accuracy, I'll talk to that a little bit here in the next of how it compares to casting, and then and MIM, I'll talk about that. Properties, always important when you talk about metal printing, is having isotropic, the right density, the right type of part so that you can use it as a metal part. Desktop's metals technology all has isotropic and material properties, and then cost and speed. So if you look at where this has been driven down, the cost and speed, the speed keeps going up, the cost keeps coming down. And so now it is that ROI is much more attainable than in the past. And so real quick, just to kind of let you know where desktop's technology, it's really based off metal injection molding, right? And so very similar, what MIM is, it's basically, it's a powder process where you create a mold, you put the metal powder in, and then you sinter it. So desktop really took that technology, the MIM technology that's been around for years and years and years, well proven out. And really what they did is they built an additive process around it. So many of you as manufacturers are familiar with MIM, that's used for very specialized tooling and very, geometries that are hard to machine or impossible to machine. And that's really what they took. They took the MIM process and created their 3D printers. And the advantage, of course, is just the ability, if you follow a MIM process, you got to tool up for that, right? You got to feed the stock in, debind it, and sinter. Now with technologies such as Studio and Shop, we can basically print that part with no tooling, right? Remove the supports if needed after sintering it, and then we're basically doing it in one process. So by far, the one thing we're seeing across the board, especially in the Midwest, is just the time to get either jigs and fixtures or parts, right, is months out, right? If you're waiting for a mold or you're waiting for machine time, everyone's busy. 3D and additive really brings that, so the ability to push and print and in a very short time get the part you want. So I want to just highlight kind of where the product portfolio is. I'm going to focus in on Studio and Shop today, but of course, this is the desktop lineup. They have Fiber, which is a composite printer, but you can print parts that act like aluminum and steel. And then, of course, you have Studio. I'll get into that, kind of the entry-level, office-friendly production printer. Then you get into Shop. I will tell you that one of the main reasons that I signed up with Desktop, and very fortunate that they agreed to let us, is the Shop system. I think it's completely revolutionary from what other technologies are out there. And then, of course, Desktop has a specialize in the production unit. And again, this is where you get to high volume, high value, high volume parts. But this is, like I said, one of the unique things about them is they really have a broad portfolio. And as I mentioned earlier, based just on their growth trajectory, they keep acquiring technologies and porting it. You'll see a wood printing technology coming out from them, which at first I didn't really understand, but it's a very unique product that I see a lot of applications for now. And they just bought a technology that will actually print using in one print multiple metal powders. So, you know, the other question comes, okay, so what's the volume that we're talking, right? And if you see, this kind of gives a slotted chart of where it fits versus traditional manufacturing. Of course, their high volume is really geared to print hundreds and thousands of parts. That technology is way above my head, but it's pretty amazing what it's doing. And then if you take the Shop system, that's where we get into either pilot runs, you know, when we talk about kind of gap printing of parts until you get your regular tooling up, or actually running mid-volume production can be done on the Shop. And then, of course, we'll talk about the Shop where you can do prototyping or one-off parts at a very affordable and effective range. So really, this is the other interesting thing about Desktop is they have a solution to fit your pain. And that's, like I said, very, very, very beneficial. So the first product I want to talk about is the Studio system. Again, them and Mark Forge with the Metal X were kind of the two that generated this technology. But the great thing about this is they've eliminated this to a two-step process. In the past, what would happen is you would print, you would have to remove some of the material in kind of a debinder and then sinter. Now it is a two-step process. You basically print and then sinter. In the printing process, most people are aware of FDM or FFF, but it basically just builds that part just like a regular FDM, FFF printer would do. It prints that part with support structures. You take that part, you sinter it, and you have your actual metal part. The interesting part, of course, that Desktop also does is, you know, as I was talking earlier, normally if you take even a laser sintered powdered part, you need to use an electric EDM or something to cut the part off of the base that it's building on. In Desktop's technology, they can actually break away the support. So I would say this technology is great for jigs and fixtures. I actually, at the beginning, when it was first launched, quite honestly missed all the number of applications that can be used. Think about parts that are hard to tool up for. Now you can print them and do geometries. It's designed for the office. Again, no special environment. You can put it right in a typical environment, and I'll talk about the separate support and a pretty wide range of media. So as I mentioned earlier, it's simply print, right? And it just prints it layer by layer, just like any additive. And if you look at that part in the first stage, the bottom part is actually the support structure. You see some support structure in the middle of the cavity. And then basically when that part is done printing on the printer, you move it over to the sintering station. Basically what you're doing then is you're removing any of the non-metal powdered, and you're sintering to make that part solid. Again, this is very typical in MIM as well, where you're taking a powdered part and you're putting it in a sinter oven to make it solid. And then, as you can see on the right, one of the biggest advantages Desktop has is there's no cutting off of the parts. It is basically a simple separable, removable support. Again, very revolutionary, and I can say just the overall output and quality has been pretty amazing in what we're seeing from that perspective. And there's a wide range of things. So the new technology where I was saying where you can basically go print to center, right, currently is 316, and you'll see the roadmap for 17.4 and tool steel. You do have some other technologies like 4140 and H13 and copper that you can print. You still got to debind it, but it just, again, an additional step. So the one other option or advantage of Studio is you have a wide range of metal material, and you can actually see the stock there, right? And what that stock is, it's basically metal powder formed so that it can be basically deposited through a print head. And so, as I mentioned, the key features are the two-step process, and then of course the software controlled workflow. I can't stress this enough. The interface and the ability, it really is a closed loop system. So when you create a part, the data goes over to the center station. It knows what it needs to do, what it's centering. It sets the parameters, and off you go. Of course, the smart separable supports is hugely beneficial. You don't have to get cut away. The hardware and the software are totally user-friendly, right? You can kind of even look down at customized settings. So one of the other advantages of 3D printing is, you can actually set infill at a different rate. This is used for lightweighting, for reduction in material, but you can actually change the type of infill you use based on the part. And then just overall, excellent material properties, high quality printing. And in fact, we have a couple different print heads based on how accurate or how small a feature you want to have. And these are just some examples that are printed off of the Studio. As I mentioned earlier, I think even at the beginning when this technology was launched by the likes of Markforged and Desktop Metal, I really missed some of the applications. If you take that bracket, right, you can do some very unique geometries. And again, just think about trying to machine that up. There's no machining. You're going to take that CAD file and print that out. So I encourage you to kind of look out on your shop floor, look at parts you're producing, and say, hey, is this a part that I can create? The impeller is another very cool one, right? That would be near impossible to machine out effectively. And so this is just an example of Eaton Corporation where they're using the Studio system to create this tooling. Again, think of the time as you're basically taking that CAD model, hitting print, getting your parts, mounting them up, as opposed to waiting for the machine time and getting it to programming it and then setting out. So as you can see there, it reduced that lead time from 3 to 4 weeks to 5 to 10 days. And that is really one of the key advantages, not only about the geometry advantages and the material advantages, but the ability to print a part. As I mentioned earlier, this is why I signed up with Desktop. Because the shop system to me is completely revolutionary. It is what's going to bring powder metal printing to the masses, in my opinion. And so what this is, if you talk about the original Studio, it's more of a print process where it's printing through an extruded head. This goes to a powder process. For those of you who've worked with MasterGraphics, we sell HP 3D, and that's what really revolutionized the composite space. Because with HP's technology, we're printing in layers. Think of it in a raster format as opposed to in points. So on the HP side, our volume for parts have shot up to the point that we're manufacturing final use composite parts. And to me, this is what metal powder allows when you're doing it by layers. And to the point, before Desktop came out, many of the powder-based metal printers were very hard to use, right? You had to have a controlled environment. You had to have very experienced key operators. This is where it's revolutionized. And I just say the screen alone, the interface is absolutely crazy. So this is scalable, it's cost effective. It actually fits in the price point of what we sell. A lot of our HP 3D print users are buying from the HP side. As I talked about earlier, it absolutely reduces lead times. It creates high quality, dense part, and it's a true turnkey system. So we did order the shop. We have it in our Wauwatosa office and are looking to set it up over the next month. So we'll do some open houses there so you can see that. And as I mentioned earlier, what this brings is 3D print accessibility to all. So I just want to quickly go over just kind of how the shop system works, and it's the middle section. As opposed to printing in points, what it actually does is it deposits the powder and actually spreads the thin layer in one pass. This is actually a little different than even our HP, because what our HP does is it brings over the powder, compacts it, and then prints it. This in one pass lays out the powder, does a very fine layer, and then deposits the binding agent to basically solidify the part wherever you want it. So think about the speed increase versus if you're trying to cure metal with a laser, you have to trace that whole part. In this case, we're actually doing it in one layer. So our print speeds are incredibly fast. And so that's exactly right. How does it work? Much similar to Studio, except now our throughput is, greatly increased. You basically print it in the printer. Again, it dries, right? Because it's actually a binder doing it. You can, and they call it cross-linking. It actually then gets the powder, so it's cross-linked together. You depowder so that you have your parts, and then you put it in the sinter oven. Again, what I can't express enough for those of you, but this is a closed loop system, right? It's Desktop created the sinter system. A lot of times in metal printing, if you had to take a powder system, you had to go get an L-neck furnace, you had to do some other process. This is all in one in a closed loop system. So the ability to operate this has, I don't want to say dummied down is not the right word, but it's much more feasible for customers to implement it. So I keep harping on it. The turnkey system, it's obviously much faster than laser point processing. You can actually see where the little light is in a laser. Even though lasers move very fast, you can't beat printing by layer. Of course, again, much like HP technology, it has high resolution printing. Because you're dropping drops, you can actually control it, actually in a lot of cases better than you can actually a laser, right? And this is, the other thing I've learned as we've gone from our 2D print world to our 3D print, jetting has a lot of advantages because of the way we can control the droplet size. And of course, there's redundancy in the print heads, much like HP. If you have a nozzle clog or whatever, it's smart enough to figure that out. As I see down lower, the simplified post-processing, same thing, break off supports. Not very, again, difficult to build supports in and actually break them off. And then of course you can build that set and build in a box, and I'll talk about that. So these are just, again, more examples. We have the impeller. We have, if you look on the lower right side, that sensor holder, we have a number of these. So at the very end, you'll see my email. If you're interested in getting a sample of that sensor holder, we can send it to you. But much like the shop, we got some examples. But as I talked about, printing in powder has some very unique advantages, not only speed, but the ability to pack. Again, it's very similar to what we have revolutionized with HP 3D, is we can build a box of parts, and we can either do mixed parts, as you can see in the first one, we can do batch parts, or we can do mid-volume production, the same part running over and over. We actually see this and have experienced this with HP 3D, very much a mix, right? That you can, again, use the machine based on the workflow needed. Sometimes we're seeing prototyping, sometimes we're seeing production. But the key thing is, because the powder becomes part of the support, you can build in that whole volume and you're not limited by the support structures. So that is really another thing that continues to make the advantages of powder printing. And then this is one that it's funny, because normally when you're talking about metal, this is the first thing they lead to, but you can do generative design in design optimization. In the case, you can see the original design is, kind of a solid object, because that's how you would machine it. But now you can actually 3D print it, actually sometimes improve the strength and functionality and lightweight it, and then print those parts. For those of you who know, we have a great relationship with D3. They have a great tool. D3 is an Autodesk reseller. They utilize Fusion 360 and do support on it. I'm amazed at what Fusion 360 can do from a generative design. You remove, you lightweight, you use less parts. And to me, this is the next phase. So traditionally, you're probably going to start with the printer, try to get some, parts out that you want. But once you start doing generative design like this, or, optimizing your design, this is the real payback of additive that you just can't do with traditional manufacturing. And of course, you can see that mass production. Here's another example of that fuel swirler. Again, we have some of these, just kind of gives you a cost of $5 per parts, but just again, look at that part. Would be impossible really, or very difficult to machine. Impossible, I guess would be the right word. But look at the throughput you can get on the shop system. And again, all of this for really what is near the price of what our HP production composite printer is. So this is what excites me. I think most of us in the industry and around, I always talk about metal printing being the holy grail. And I just look at what Desktop has done here. It excites me why we brought them on a partner, and quite honestly invested in a shop system just as a demo so that we can understand it and show our clients it. So the last thing, I keep highlighting the production system. Again, this is kind of Desktop's foundation. This is truly a single pass, high volume, very cost competitive. This is not an entry point printer, but to me, they are a market leader when it comes to production systems. And just to be candid, HP is working on technology, not quite similar, but again, this is kind of the future of metal printing at a high volume. And again, if you have an application you think, I can connect you with Eric. And then of course, my last one, I just wanted to point out, they are launching this fiber system at the, I think, third or fourth quarter. And what this allows you to do, it's a low cost entry level system, but because of the inlay carbon fiber, you can make parts that are very strong and work like aluminum. A lot of jigs and fixtures, that type of thing we see done on that for sure. And then let's see on my last slide. Oh, and this is just to show, again, Desktop Metal, it's almost hard to keep up with what they're doing, right? In the last 6 months or year, they acquired EnvisionTech. You can see EnvisionTech's strength was really, composites. They could do production type plastic printing as well. And then of course, the wide range of Desktop Metal parts. And so they're going to continue to expand this portfolio. And I say that's one of the advantages that we have at MasterGraphics is, I believe, bring on best-in-class 3D print manufacturers. And what it allows us to do is go into our clients, see what their pain are, and in more times than not, we have a product that should fit. And again, we're also open to when we don't have a good fit. So with that, you can see my number, my email on there. If you want to email me, I'll send you some part samples off of the Desktop Metal shop system. Even if you just want to talk, connect, I'm always willing to talk about additive. And this metal is a different thing. It's going to be a learning process for us as we move forward. You can obviously visit our website. And I do have a podcast called Chatting 3D. I try to make it fun. I love talking 3D. If you are passionate about 3D and you want to be a guest, reach out to me. It's more of a fun podcast. I try to make it informative. I bring on products we don't even sell just because I want to have some fun with it. So with that, I just want to go through some questions that we got while we were going forward. And I don't know, Eric Gold, if there's anything you want to unmute and add since I did all the talking.
No, thanks, Kevin. Can you hear me okay?
Yep.
Yeah, first of all, thank you for doing this, and I appreciate everybody's participation. The one thing I'd like everybody to know about Desktop Metal is that Kevin hit it at the beginning. The goal here is to make additive metal accessible to everybody. I think about the early days of CAD when you had CAD operators that were actually specialists in CAD. They weren't just designers, they weren't just engineers, but they had to be really specialists in what they did. And then some of these mid-range tools came along and created workflows and automation that allowed more accessibility to more people, along with obviously it being ported over to Windows. And that's where Desktop Metal is right now, is making it accessible to everybody, taking out a lot of the PhD level information that you need, the black art that goes into some of this stuff. We're trying to take a lot of that away and really create and make it accessible. And then when Kevin talked about the acquisitions that we've made, if you notice and if you kind of follow it, everything that we're doing is around taking companies towards production. And Kevin mentioned scratching your head when you looked at wood. This has been amazingly interesting to a lot of big companies, automotive and furniture and all these kinds of things. And when you talk about EnvisionTech and when you talk about the multi-material, it's all about allowing companies to go from very low volume to getting to high volume production. So if you follow us, that's what you'll see. The goal is to be able to take you all the way through and provide a true vision and a true strategy towards complementing traditional manufacturing with production applications. So again, Kevin, thank you very much. I hope I'm just kind of putting a cherry on top of the points that you've already made.
No, thank you, Eric. In fact, I should have had you speak sooner. We thought Eric was traveling. He was able to join us, but no, great input. And hey, Eric, I had 2 or 3 questions, and one you can help, and I know I should know this. Material roadmaps for shop, right? Is there anything public announced on like next materials that you believe will come out on shop?
Absolutely. So today we're focused on 17.4 stainless. And if you look at our website and you go to the materials section, you'll see everything that we're working on for all of our systems. What we've announced coming, and hopefully later this quarter, we're trying not to overpromise, is 316L stainless as well as cobalt chrome. And cobalt chrome is going to be really interesting for a lot of applications. Those of you who followed metal additive will see that it's been great for aerospace, but also for dental applications, which is really interesting. We're trying not to promise too much around there or beyond those, but those are the next ones that are coming.
Great. I had another question from Donnie just asking if we can do like an award like Oscar award, not the base part and name, just the actual award. And again, of course, that is it's additive, right? So in fact, you can print the base and the name on it. That's the beauty of it. Obviously, in the case of an award, there might be some post processing, but I'm trying to think of the company that I worked with almost 7 years ago. And we did actually that process where we were building like Oscars and Emmys. And so the answer is absolutely, right? And in fact, I would take it a step forward because you said not the base or the name, but that's the beauty of additive is you can do, the names, you can make it customized. You can print 100 different awards with different names. So that's one, if you do have an application, definitely reach out and Eric and I can and talk through that. The other one was, the question was just a ballpark figure for studio. And so studio is again, kind of that entry level FFF. And I believe, Eric, you got to confirm me, what is that 160 pretty much ready to go?
Yeah, somewhere, it depends on the configuration. It's probably a little bit closer to 190 to 200, but yeah, it's right in there depending on a couple of added features.
And the other thing I'll add to that, when we look at additive, a lot of times people go out and try to budget, let's say it's 190,000 for the unit. But what I found is it's mostly a monthly ROI that you get. So we have some unique acquisition ways, whether it be lease, whether it be rental, and so sometimes it's hard for companies to go out and justify that budget. But what I found really is effective, if you look at it at a monthly savings, can you figure out that savings? And, we can break that down and offer a monthly type contract to bring it in. Because the other thing I've learned in additive, it's not 100%, but 80% of the time someone brings in additive, the applications skyrocket through the roof, people use it. Very rarely has someone not got the return on investment from additive. So I think that was the last question I had. Anything last comments, Eric, if anything else?
No, just to piggyback on that, the way that we help companies to justify it, working with Kevin and his team, is we have a great cost modeling application where we can go through, we can evaluate what you're doing, and before you even get to having to print and test parts, we can give you a good idea of how our process would fit, whether or not the applications and the parts that you're looking at will fit. And we're happy to run through these with you and to both educate you and to give you a good comparison between the way that you're doing things now and the way that you'd like to do things in the future. You know, I know a lot of us are sitting back and, you know, supply chain for things like castings and anything that's created overseas has been completely interrupted over the last, you know, year and a half. And so if the future is we want to control this, we want to bring it in-house, we're just not sure of the financial justification or the validation, you know, Kevin and I are happy to work with you and to figure this out collaboratively.
Okay, and one last question came in, and then I will wrap up. Is someone was just what's the cost per part on the shop? Again, there's a lot of variables in there, so I just encourage you to reach out to us if you have an application, because volume, size, obviously affect that. And the other thing, just to kind of go back to our defined process at MasterGraphics, look, we realize that 95% of the people we have in conversation are not ready to bring this the equipment in-house in a short time frame. But what I find is too often customers or clients engage us late as opposed to early, so that we can really nail down the right solution. So I just assure you that we are not a high pressure closed company. We've been around for 72 years by doing the right thing for our clients. And as I mentioned earlier, we're passionate about it. We do okay with it. We don't need to pressure sales. We want to do the right thing, because once we do, our business will grow with you. So like I said, even if you have a wild hair idea and you're like, there's no way I'm getting budget, this doesn't make sense, we love to have those conversations. And like I said, with all that Desktop is doing, sometimes there's something that they may be coming out with. And if we're aware of your pain, there might be a better product that comes out that is accessible to you that wasn't in the past. So as I mentioned, feel free to email us. I appreciate you attending. We'll set up a follow-up email with you. And but I appreciate you taking time out of your day to join our webinar, and hope you continue to have a good Tuesday. And thanks, Eric, for the input. I probably should have had more of your involvement so you could have made it interesting. So with that, have a great Tuesday, everyone.